Hello friends, welcome back to my channel Medicine of 101. Today we'll talk about bipolar leaflets part 3. Okay, before starting the video, let me tell you I have already uploaded the two videos in terms of the bipolar leaflet part 1 and part 2, where I have discussed already how the limbs are formed and what are the things in terms of the axis of the lead, pattern of the lead, all these things. Now in these cases I'll talk basically in terms of the pathological, kind of the pathological conditions within the heart. For that still we will get what the Einthoven's triangle that fixed. There will be no change in the formula of the Einthoven's triangle. So what did we learn last time? Bipolar limits means basically we will get the two what electrodes. That means we will get the two poles that will form the two electrodes. So if we write it over here in these directions, we will get the here. Okay, let's so here we will get the needle that will fluctuate, and one will get what that will be attached to the positive, another will that will attached to the negative poles. Now this positive electrode, that is also known as what? That is also known as explore electrode, or it is also known as reference electrode. Now let's go back to the normal thing in terms of the normal Einthoven's triangle. What do you say in terms of these things? Try to remember. I said that, for example, is the lead number 1, axis of the lead number 1. So we'll get over here, negative, positive over here. Then I took this one what? Lead number 2. And I took over here lead number 3. So for example, it's the lead number 1, it's the lead number 2, it's the lead number 3. Okay. What did I say you in these cases? Try to remember that when you are talking in this way, that what is the formula for Einthoven's triangle, that if we get the voltage or the potential difference in the lead number 2, that is nothing but the additions of the lead number 1 and lead number 3. So if you write it over here, 2, that is equals to 1 plus 3. How it's coming? Let's repeat once again. Normally what do we know? If we just consider the heart over here, for example, if we just consider the heart over here, what do you know? That whenever you are talking in terms of basically over here in terms of the major ventricular depolarizations. So during major ventricular depolarizations, we'll get the major vectors. The vectors that will be produced for it will get in these directions. Now see the directions for it, or along with the it's parallel to the lead number 2. It's along with the what? The lead number 2. In these cases, we'll get the more fluctuations. Why will get more fluctuations? I have already said. So if we will get in these directions, if we get in terms of this is where we'll get the more fluctuations over here. Now see in terms of lead number 3, see we'll get little portions that will be perpendicular to the what? Perpendicular to the major ventricular depolarizations axis. Okay. So here we'll get what? Little fluctuations. And if you talk in terms of the lead number 1, see, in terms of the lead number 1, if we just make the perpendicular, we'll get only this much portions. So for this much portions, we'll get also the small depolarizations over here. Now if you do the additions of this, then you can get like this one. So if you write it over here, this equals to 1, for 1 we'll get small, plus 3, we'll also get the small fluctuations over here. Now if we add, then we'll get what? The lead number 2, the potential difference in the lead number 2, that is will be the what? That will be the additions of lead number 1 plus lead number 3 over here. Now we'll talk about in the different kinds of the pathological aspects. For example, if we get the major ventricular depolarizations, the vector, if we don't get in these directions, instead of that, if we get the directions of the major ventricular depolarization in the other directions. For example, let me show over here. So we got for these directions this one. Okay. Now let's show over here. For example, I am drawing it again. This is the negative, the positive one. Again from here we will get what? Positive one. And here it will be what? Negative. Again it will get the negative. We will try to make it positive over here. Yes. Now the threads are found over here. So the lead number 1, lead number 2, and lead number 3. Now, for example, we are getting the major ventricular depolarizations known in the left node and down node. Normally, what we see over here, or rather, if we get, okay, let's over here. For examples, we are getting the major ventricular depressions in these directions. We are getting the major ventricular depression in these directions. As a result, what do we know? Definitely the fast lead that will have the much more what perpendicular areas with respect to this one. So definitely the fluctuations in the lead number one, that will be much more over here. See, it will be much more over here. Now she has the directions in this direction. So the directions for the vector for the lead number 3, that will be changed right now. It will be in this direction. So whenever the directions will be in this direction, that means see the positive electrodes from the negative. That means the positive is going towards the negative. So definitely the deflections, that will be negative. What did I say you? Whenever we will get the positive deflections, when we will see the positive deflections, whenever the positive charge that will go towards the positive, or the negative one that will go towards the negative. But here we are getting, if we get for example the pathological ventricular depolarization in this direction, that is parallel to the lead number 1 in this cases, so we will get the major ventricular depolarizations over here, and for the lead number 1 we will get the much more what deflections over here. But if you talk in terms of the lead number 3, try to understand, as if the directions will be opposite for it, so we will get definitely the what we will get the, and we will get the very little amount of what perpendicular portions from here. So as a result we will get what the negative depolarization in these directions. And what about lead number 2? Lead number 2 in these cases will get, try to understand from here. Okay, let me show with them with this one only. See, in the lead number 2 we will get also the very small portions. Okay, now try to understand from here. In lead number 2 we will get what the positive deflections. Still it will have some positive effect over here. So we will get some positive deflections. Now see, try to understand from here. If we just do the addition, if I just do the additions for the lead number 2, if I add the equations over here, equals to lead number 1 plus lead number 3, then how can we represent in terms of this ECG? So you got the very, not that much, stronger depolarization will get just, moderate over here. In terms of the 1 will get what? Major. But it see in case of what? We will get the negative depolarizations. For example, over here for lead number 3. So you will get, if you do the minus, ultimately we will get the potential difference, that will be equals to number 2. From here we can also write in this way. Now we will talk about another kind of the major ventricular depolarization in another directions. Let's show that. Now for example, I am just drawing over here. Okay, I am erasing this part, guys. Okay, so I think it will be easier for you to understand the rest parts. Now for example, I am just taking the negative, this is the first lead, positive over here, I am getting lead number 2, and from here we will get lead number 3. So negative, it is the negative also. Is the lead number 1, is the lead number 3, and is the lead number 2. Now for examples, we are getting the major ventricular depolarization, that is parallel to lead number 3. And the first things we got, normally what we get in these cases, what leftward and downward, that will be the parallel to the lead number 2. For it, what do you got over the normal equations from the what Einthoven's triangle. In the second cases, I did talk about, for example, we are getting the major ventricular depolarizations. The axis of this one, the axis for this vector, that is parallel to the lead number 1. Here we also got what the same equations. It will be still the fixed. That means we will get ultimately the additions of the 1 and 3 leads, the potential difference, that will be equals to the potential difference for lead number 2. Now let's see over here. Now we are getting the major ventricular depolarizations, for example, in these directions. Okay. Now try to understand for the lead number 3, whatever thing will see the major portions for the lead number 3 will get over here, that is parallel to, if we just draw the perpendicular, we will get the parallel to what? Lead number 3. So the major ventricular depolarizations we are getting, that is parallel to lead number 3. So definitely we will get the depolarization that will be stronger over here. Okay. Now think about lead number 1 and lead number 2. Whatever the thing will get over here. Now see, if we just draw the line over here. Okay, let's draw with this color only. See, if we draw in these directions, for the lead number 1, we are getting in this direction. See, it will be in this direction. So definitely, directions for the lead number, lead axis 1 will get in these directions. Try to understand, it is coming, in this direction. So definitely it should go in these directions. Now, whatever the thing will get over here, definitely the little portions that is getting messed. If we just draw the perpendicular from here, but see the positive, we are getting the positive charges going towards the negative. So definitely the deflection that will be negative over here. Okay, for this one. And what about this one? If we talk in terms of the, see, if we talk in terms of the number 2, see, if we just draw the perpendicular from here to here, the directions will be in this directions, no problem. Okay. Now see lead number 2, we are getting also little portions, so we'll get the positive reflections, but not that much. Okay. Now if you do the additions over here, try to understand. If we just do the addition, whatever the thing will get over here. If we just do the additions, so lead number 2, that is just lead number 1 plus lead number 3. So for lead number 2, we got only what the small deflections over here. For lead number 1, we got the negative deflections, and for lead number 3, we got stronger deflections. See, if we just do the subtract, then definitely we are supposed to get lead number 2. So still see, we are getting the what? The Einthoven's triangle that is getting messed over here. There is no problem. So any condition, this may be the under normal physiological circumstances, or if you see the pathological conditions for what we are getting the directions of the major ventricular depolarization that is getting changed. When it will get changed, the directions for the major ventricular depolarization, still will get the what Einthoven's triangle, and that will be messed for everywhere. Okay, that is fixed, constant. Now we'll talk about some more other cases. For example, we are taking the the negative, the positive. First lead we are getting the second lead number 2, and we are getting the lead number 3 over here. Okay. Now see, is the what lead number 1 is the lead number 2, we have already written it, and this is the lead number 3, I am writing it over. Okay. Now what are the thing, I am getting the major ventricular depolarizations. I am getting the major ventricular depolarizations that is coming towards the corner of this portion, that is coming towards this corner. Okay, in between the lead number 2 and lead number 3. Now see, whenever it will just come perpendicularly, at that time whatever the thing we'll see over here, if we see in terms of the lead number 1, so for example is the lead number 1, and whenever the major ventricular depolarizations that is coming towards perpendicular directions with respect to lead number 1, definitely we will get at first it is coming, then after just whenever it is touching the lead number 1, it is going away. So whatever the thing we'll see over here, at first we'll get the positive reflections. After that, whenever it will just touch and it will cross away, again we'll get the what? Negative deflections. Ultimately we'll get the 0, we'll get 0 deflections over here. We'll get 0 over here. Okay. Now try to understand from these two, whatever the thing we'll get, as it's perpendicular, so for the lead number 2 and lead number 3, you will get the same portions over here. So whatever value we'll get for lead number 2, the same portions we'll get for lead number 3. Whatever the deflections we will see, because see the equal, we are getting the equal that is getting matched with the major ventricular depolarization axis. That is the perpendicular over here. Okay. So here, if we get in these directions, just like this one, positive deflections, in the same way we will get what? The positive deflection in these cases. So we can write it over here that lead number 2, that will be equals to 1 plus 3. As I already said you, that 1 that will be 0. So we can write for the lead number 2 in these directions, for example, so 0 plus it will be in this direction. So ultimately it is proved. Okay. Now for example, so we are getting the major ventricular depolarization axis in another directions. So let's over here. Okay. Negative. The positive over here. The positive. Okay, now see. Positive, we are getting the negative to make the what? Lead number 2. We are getting positive over here. We are getting positive. And we are getting negative. Now lead number 1, lead number what? 2 and lead number 3. For example, in these cases, we will talk about the the major ventricular depolarizations that is going in these directions. For example, that is going in these directions. So whenever it will go in these directions, try to understand. Definitely, for lead number 2, the directions for the major ventricular deployment that is perpendicular. So if I just draw the lead number 2 over here, try to understand is the lead number 2. At first, if we draw, it is coming, it is going away. It is coming, it is touching, and it is going away. So whenever it will come, at that time we will get the positive deflections. So whenever it will touch and go away, after that again we will get what? The negative deflections. So the result we will get what? We will get the zero potential difference over here. But what about lead number 1 and 3? See the same portions that is getting parallel or matched with the lead number 2 and lead number 1 and 3. So whatever the major ventricular depolations we will get over here, in these cases, that will be parallel wire with lead number 1. But in these cases, we will get the positive deflections because it is going positive in these directions. But try to understand, in case of the lead number 3, the directions, what? It is supposed to be in these directions for positive, but in these cases, the vector that is going in these directions, so the directions for the lead number 3, that will be changed. That means what? We will get over here the negative deflections. So whatever, because we are getting the same portions for lead number 1 and lead number 3, so whatever we will get the deflections in terms of the lead number 1 is positive, the same amount of the deflections we will get in terms of negative for lead number 3. So we will get this one. Now if we just add this thing, what the thing we will get? Now let's compare and contrast lead number 2, that is equals to 1 plus 3. So if you draw, we will get 0 over here. And for 1, we will get the positive deflections, and this one we will get the negative deflections. So if we show negative deflections, it will be minus, then directions is opposite, so ultimately we will get 0 over here. Okay. Now another case, for example, okay, now this direction down, now we'll take the major ventricular depolarization that is going towards these directions, this corner. Okay, for that thing again let's draw negative or positive lead number 1. Okay, so reading lead number 1, lead number 2, lead number 3. Now I am drawing the major ventricular depolarizations, for example, in these directions. It is coming perpendicular in this direction. Okay, now see. For lead number 3, same cases we will see over here. That is just what? That is perpendicular with respect to lead number 3, the major ventricular depolarization, that is perpendicular. So it will come, it will touch the lead number 3, again it will go away. For that thing we will get what? We will get the same type of the thing we will get over here. We will get, it is coming, if it is crossing, ultimately we will get 0. Okay. And what about lead number 2 and 3, lead number 1 and 2? See the same portions we will get over here. We will get the same portions. We get same portions. See, lead number 1 from positive to negative. So definitely we will get the deflections, but the deflections that will be negative deflections because there's, the directions of the major ventricular vector axis over here. The vectors for the, or you can say the directions of the vector for major ventricular depolarizations with respect to lead number 1 over here will get positive to negative. That means the deflection that will be definitely negative. So we'll get the negative deflections over here. In the same way, see, in these cases we will get the same amount or the value that will be same with respect to the perpendicular things over here with respect to lead number 2. But here also see the positive is going towards the negative, so definitely the directions that will be also reverse. So the directions reverse, so definitely the value that will also reverse. So we'll just say we'll get in these cases this type of the thing. So ultimately, if we just draw that 2 equals to 1 plus 3 over here, and try to understand, in 2 we got this one, the deflections but negative deflections. For the 1 we also got the same thing. But for 3 we will get 0. So ultimately we can prove everywhere the Einthoven's triangle that is getting matched. So there is no fun in telling these things that there will be no proof. That means we can say Einthoven's triangle that is constant. So whatever the things, it may be the physiological or it may be the pathological conditions, ultimately we will get the Einthoven's triangle that will be proved everywhere. Okay. Now we'll talk about the orientation relationship in between the axes. Okay. So for that thing I have to erase some portions. So which portions should I erase? Yes, let's erase these portions. Okay. Now if I write it over here, oriental relations oriental relations among bipolar limb leads. Bipolar limb leads. For that thing, for example, I'm just assuming that, okay, let's say I'm drawing the heart over here. Okay, now try to understand. What do we know? That the different kinds of the vectors, axis will get the negative, positive. For example, we'll get the lead number 1 over here. For that thing again, let's draw. We'll get what? We'll get the positive over here. Definitely we'll get negative. Lead number 2, get negative, we'll get positive over here. Okay. Now try to understand from here. We'll get definitely it's the lead number 1, it's the lead number 2, it's the lead number 3 over here. No problem to understand up to this much. Now if you consider a circle over here, try to understand. If you consider a circle, whatever the thing will get over here. Okay. Now see, if we just draw the in axis for the lead number 1, for example, I am drawing in these directions. Okay, let's draw the axis. Okay. If I just draw the lead number 1 over here, okay, and if I just draw the lead number 2, that means this one over here, okay, and I have just drawn this one lead number 1, and I am just dividing this whole circle into 4 directions. If I just divide this whole circle into 4 divisions, definitely if we consider this whole 360 degree, definitely try to understand from here. I have just taken this first lead over here, I just did the first leads over here, and try to understand, I just made the circle into 4 divisions, that means each will be 90 degrees. Now in terms of the ECG, in these cases, whenever we get the positive deflections, in this case, that means towards the positive side, with respect to the leads, we have to consider the positive values. So definitely, whenever it is coming in these directions, the positive things that will be over here, that's why I'll consider these things, this value over how much? Plus 90 degree. So I'll consider this value how much? Plus 90 degree. We'll get plus 90 degree. In the opposite directions, we'll get how much over here? We'll get minus 90 degree. And I have to consider this as straight line angles. So it will be, if we just consider it will be 180 degree over here, it will have to consider 0 over here. We have to consider 0 degree. Okay. Now, if we just draw, let's draw the different angles for this one. So if it is 0, for example, it's the 0, I'll just take intervals of the 30 degree. For example, it's the 30 degree, we'll get how much? Positive 30 degrees, positive directions. For example, I'm just taking this positive 60 degree, it's the 90 degree. I'll get how much over here? Plus 120 degree, I'll get positive 150 degree, I'll get positive 180 degree. In the same way, if we just go upward, definitely try to understand this positive going towards the negative. So we have considered what we have to consider: minus 30 degree, minus 60 degree. Sorry, let's draw the minus 60 over here. This is the minus 90. Here we will get minus 120 degree. Here we will get minus 150 degree. And here we will get the plus minus 180 degree over here. Now, with respect to the legs, whatever thing we will get over here, try to understand from these things. Okay. So let's draw these things over here. Just normally, I will just draw the axis. Okay, 0, it's 180. It will be how much? Sorry, it will be 0 because the axis in this direction, that is positive. So it will be plus 180 degree over here. Now in these cases, it will be how much? 30 degree, 60 degree. Definitely it will be positive. It will be plus 90 degree, plus 120 degree, plus 150 degree. We'll get plus 180. The same we'll get minus 30 degree, minus 60 degree. We'll get how much? Minus 90 degree, minus 120 degree, minus 150 degree, minus 180 degree. Now we have to talk in terms of the vectors. Now see the lead axis. If we say in terms of the lead number 1, that should go, if we just draw from here to here, definitely it will go in this direction. So the lead number 1 will get the directions in this cases. So it will be the lead number 1. So if I say it will be lead number 1 over here. Now if I say in terms of the lead number 2, okay, let's draw from to here. See, if we say in terms of the lead number 2, if I just draw these portions, that means lead number 2, if I just put this over here, whatever thing we'll get over here. See, in terms of the lead number 2, if I just draw, I will get in these directions. Okay, let's draw the different color. Let's draw with different color. From here it will come towards the plus 60 degree. So it will be the for lead number 2 over here. It will be for the lead number 2. I think we need to draw it more clearly, and I think it will be more easier for you. Now if you see in terms of the lead number 3, try to understand. If you see in terms of the lead number 3, the lead number 3 is over here. In this case, lead number 3. If you draw the lead number 3 in the same directions, we'll get the lead number 3 that will come in these directions. It will come in this direction. So it will be for the lead number 3. So this will be for the lead number 3. This will be for lead number 1 lead, and what this is the lead number 1 0, and for the lead number 2 we get how much? Plus positive 60 degree. For lead number 3 we get plus 120 degree. That means if we see over here that for lead number 3, for the lead number 3, try to understand from here how it will just watch, how it will monitor the heart. If we say for the lead number 3, see is the lead number 3, is the lead number 3. So it will monitor the heart at what? Plus 120 degree, and it will what? Right, it will just see what? Leftward and outward. That means lead number 3, it will just monitor the heart plus at 120 degree upward and leftward, upward and leftward. And what about lead number 2? See, lead number 2, it will monitor the heart. Lead number 2, it will monitor the heart at plus 60 degree, and what? If we say the directions, that will be what? Upward and rightward, upward and rightward, upward and rightward, rightward. If you say in terms of the lead number 1, the lead number 1 that will see the heart at what? 0 degree angles over here, okay? And definitely it will what? Cross-linking, that means in the transverse axis you can get over here. So this was all about in terms of the bipolar limb leads part 3. Now we'll talk about the augmented limb leads or unipolar limb leads. There I apply this concept over here. Okay. So if this video is helpful for you, please do like and subscribe my channel, and see you in the next video soon. Okay, about the augmented limb leads.